Hello everyone, welcome back once again to our little talk about RoboDK. If you remember, last time we positioned all the models that we created or imported from the RoboDK library inside our 3D world. So now we are ready to start telling the robot what to do. We are ready to create our simulation, programming the robot for its task. Before actually doing that, we need to have a look at the robot, at how to move the robot, how to specify positions, orientations, and also we're going to have a very short look at the tool, how to create a tool, how to specify TCP, stuff like that. So, if you remember last time when we were arranging the simulation tree, we just dragged and dropped this simple gripper, this geometry that we created inside the robot, inside the UR3E. And it automatically got imported as a tool. So it was present in the simulation, but it was in another reference frame. Like for example, it was here in the table frame, and you can see it. It's just a regular object. When you drag and drop it inside here, you can see the object has automatically been transformed to a tool. So actually, RoboDK for the basic tools does all the work for you, or almost all the work for you. So actually, every object that is within a robot is automatically a tool for that robot. You can have multiple tools. The one with the green dot over here is the active tool. Okay, so it's the tool that the robot is going to use for whatever we are going to tell him to do. Just the same way as you could have multiple TCPs for the same robot in Polyscope. Also here you can have multiple tools for the same robot. Okay, when you double click on it, you will get the options that will allow you to customize this particular tool over here. And you can see that they are a little bit different from the options of a regular object. A regular object would allow you to position itself with respect to its parent. Instead, a tool, the option inside the tool is the option of specifying a TCP with respect to, in this case, its robot flange. So in this case, the UR3E flange. You can see this reference frame over here in space is its actual TCP at the moment. Does not make much sense as it is right now, so let's correct it. If you remember when we created this geometry, the tool is actually 30 millimeters high, so we can actually just scroll down this value to the correct value. But you can also have a look, I mean, you can check visually in case you do not know the exact dimensions of your tool. You can just adjust these values and try and correct them a few times until you get them right. So this for positioning the TCP. In case you needed to move the geometry with respect to the robot tool flange, which I honestly do not advise usually to. I usually advise to create your geometry, to transform your geometry so that the origin of the model is correct. It's actually will coincide with the origin of the tool flange. Okay, so you don't need to move the geometry, but in case you wanted to move this tool geometry, you could snap on more options, and this second position will allow you to move the geometry with respect to its reference frame. So you could actually keep the TCP fixed while moving the geometry, but I usually do not advise you to do so. But okay, this much is for the tool, so very, very simple. I told you you can have multiple tools. Here, if you right-click, you can snap whichever the one you want as the active tool. Okay, once you have a properly defined tool, both geometry and TCP, and you made it active, if you double-clicked on the robot, you will see this panel opening up for you. You can see it's a little bit more complex than the one we are used to for objects and for tools. What do we have here? We actually have a lot of stuff. We are not going to use doll, so we're just going to have a look at a few parameters inside this one. You can rename your robot, first of all, here, in case you have more than one robot. RoboDK actually does it for you when you copy paste it, if I remember correctly, but in case you want, you can do it. Here you can change what is the active tool, and you can specify its TCP. So actually what we did by opening the specific tool, you could do it automatically from here. You cannot adjust the tool geometry from here, but anyhow, you should not be using that too much. So that should not be an issue. Then what do we have? We have common movements for the robot. So basically, all this part is related to moving the robots are in the world. Usually, what you do is you move the robot with respect to a reference frame. Here you can choose a reference frame, whatever reference frame you want. And then you will have the chance of positioning the tool frame with respect to the reference frame that you just chose. Okay, so for example, I could do this and it wouldn't be, yes, it is, sorry. As you can see, the coordinates you can see here are changing. Oh, sorry, I was looking at the Z coordinate, but of course the Z coordinate is a constant in this case, but the X and Y coordinates are changing as I change the active frame. Once you have selected a reference frame, you can directly edit these coordinates and the robot will automatically move its tool to the correct position if it's reachable. You can either scroll up and down using your scroll button on the mouse, or you can directly insert a value. You can see 6 values, pretty much like in Polyscope. First 3 values are the position of the TCP in millimeters. The second 3 values are its orientation, the orientation of the reference frame that is attached to the tool, to the TCP. And actually here things get a little bit more complex, meaning that RoboDK will allow you, if you press on this menu over here, to choose among a lot of different possibilities, different conventions. You can use quaternions, you can use our notation, like notation vector. I usually feel very comfortable with the default one, which are Euler angles. So you can just get here and then change these values, which are in degrees in this case. But you can do however you see, however you are more comfortable. Okay, you can see that you can fairly easily adjust the tool position in space using this. Another way to move the robot is instead using directly this little part over here. Here you can specify a reference frame that is either the tool frame, the reference frame that you specified above, or the robot base. And you can then pick a direction and scroll up on down or down. Both translation and rotation are available. So you can actually move the robot one direction at a time. So this is also useful. This command over here will allow you to show the robot workspace. This can be fairly useful, meaning when you're creating a layout, when you're configuring a layout, it's fairly useful to know if the objects are give or take within reach. But okay? Usually for programming afterwards, you usually keep it disabled. And then we have the possibility of moving the robot one joint at a time. Not very much often used, but that's possible. Before looking at this part, last way you can move your robot, which is actually a fairly convenient one, you can go over here and select this button over here. You will see that once you toggle it on, all reference frames will add a few arrows to themselves. You can use this command to move the actual reference frame just by dragging. So you can zoom, you can grab any of these arrows and you can use it to move the reference frame in space. If you happen to grab a normal reference frame, it will move itself normally. If this reference frame has any child, the child will move with the reference frame. If the reference frame that you are picking is the tool center point, is the TCP, the robot itself will move so that it reaches the TCP's position that you are specifying. Also notice that there are straight arrows which allow you to translate the robot, and there are these curved arrows which allow you to tilt the robot. This is fairly intuitive and fairly quick way of moving the robot, so I usually use it quite a lot. It's not very much precise, but you can always come here once you reach pretty much the point where you want the robot to go, and then adjust the values. So you can think of it as if it was a RoboDK own version of our free drive function. Okay, so this is pretty much it for moving the robot. The very last part that we're going to cover in this very short video is this one, because it's very, very convenient, very, very useful when you are adjusting or creating new layouts. As you can see here, it tells you others configurations, meaning you can choose other configurations of the joint coordinates that bring the TCP in this exact same position and orientation. You can just open this list. You can select any value from the list, and the robot will automatically bring its joint to the configuration that you specified. In this case, actually, only few of them make sense. Actually, in general, only few of them will make sense. RoboDK does not check whatsoever on the fact that these configurations are colliding or not with anything in the space for now. We will see later on how to do it, but for now, these are just all possible configurations that are within the joint limits. This can be fairly comfortable, fairly useful in case you're trying to do something. For example, your wrist or your elbow is colliding with something, or there is not enough room. It allows you to check very quickly what are the other options, what other possibilities, to see if there is a feasible one that can do the job that you are trying to do. So especially when creating the layout, it's fairly useful for deciding the robot's starting position, the robot's starting configuration. Okay, this could be pretty much it concerning how to move the robot, at least for now. Now we are ready to start actually programming the robots, so we are actually ready to start creating the robot programs, specifying positions and stuff like that. But we'll do that in the next video. See you next time.